For our lesson today, we'll be dealing with the first of the combinatoric sections, which gets into some fancy formulas. This is called our permutation section. Also, later on in the video, I am going to be using my three-phrase or three-word ideas to ensure that everybody is going through these videos trying to get some information out of them. Today's topic is going to be Marvel superhero movies. All right, let's get started. Permutations. The first type I'd like to talk about are being able to arrange a small portion of a big group in a particular fashion. So from n people, let's say there's 50 people, I'm going to take 10, that's my R, and I'm going to rearrange them. Order in this is very important. By definition, permutations are n factorial divided by n subtract r factorial. First example. Suppose I have 36 students in a class, and I want to create a really interesting group with 4 of those people. They're going to have very particular titles. That's what's going to help us to understand that order is important. The first is going to be Miss Sunshine, the second, Miss Certificate, the third, Mr. Nobody, and the fourth, Sir, I Don't Care, which is very similar to the approach that Captain America took in the movie Winter Soldier. So my question is, how many ways can we create this committee? Well, effectively, all we need to do is say, from the 36 people, I'm going to pick 4. The formula goes 36 factorial divided by 36 minus 4 factorial. You can see when we rearrange this, we end up with 36 factorial on the top, 32 factorial on the bottom, and portions of that cancel. So I've just got 36 times 35 times 34 times 33, which is just over 1 million. This can also just be plugged into a calculator. It is, however, important you're able to do this by both methods. So on the calculator, there's a button, an NPR button. You should be able to find it somewhere. Suppose I want to make sure that only girls in the class can get the girl titles and only boys in the class can get boy titles. And let's also suppose that there's, out of those 36 students, 18 of each. What I would do is I would just essentially break this down into 2 pieces. The first piece, girls only. I'm a little bit ahead of myself. Girls only. From those 18, I would pick 2 for the girl titles. The second group, boys only. Do the same thing. I multiply those together and I'll get my answer. For the second part, I'm going to look at arranging n objects, which are all very similar to one another. So I might have n total objects, let's say 50. 10 of them are identical to one another. 20 of them are identical to a second set, another 5, a third set, and so on. So the way this is going to work is there's a little formula to deal with this. And I know some of you are getting tired of formulas. You're thinking this is like the Dark World from Thor. The formula states that I just take the number of objects, factorial, and divide it by each one of the smaller portions in a factorial method as well. So an example is I've got 4 people. 3 are girls, 1's a boy. This is a super small example so that I can actually show you that there are, in fact, 4 ways to line them up. Boy, girl, 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 boy, girl, girl, etc., etc. I can't tell any other way than doing it this, but there's my 4 ways. If I use the formula, it would be 4 factorial for the total number divided by 3 factorial, the 3 girls, which are all just girls, and the 1 factorial, the 1 boy, which is just a boy. There's 4 ways to do it. Another example of this type. And this last one is going to seem ridiculous, kind of like Ultron did in the movie Age of Ultron, the second Avengers movie. Suppose I have the word balloon, B-A-L-L O-O-N. There's 7 letters in this word. 2 are L's, 2 are O's. How many words can I make? 7 factorial divided by 2 factorial, which is 1,260 ways. And true, some of those words are going to say labun. It makes no sense, doesn't matter. Here's your homework. Have some fun with it. And I'll see you very, very soon when we resume Zoom lessons. Bye for now.